Okay, the next part of your organic chemistry, we are going to look at the individual homologous series, starting from alkanes, which is your carbon single bond. Okay, so alkanes, they are hydrocarbons that contains only carbon and hydrogen. Alkanes are obtained directly from fractional distillation of petroleum. So each fraction that comes out usually is an alkane. Okay, alkanes are saturated hydrocarbons. So what do we mean by saturated? Saturated means they contains carbon single bond only. That's not the end of the story. Continue to write. Each carbon is covalently bonded to 4 other atoms. No new atoms can be added anymore. Okay, your carbon only has 4 outer electrons. So this is your alkane. There is 4 lines coming out. All the 4 valence electron is used for bonding. No other atoms can be added anymore. This is your simplest alkane, methane. Okay, alkane follows this general formula CnH2n plus 2, where n is the number of carbon atoms. Okay, alkane must contain your carbon-carbon single bond. This is the functional group. Okay, this is your functional group. Okay, because they have the same functional group, they have similar chemical properties. They will undergo the same type of chemical reaction and they will show a gradual change in the physical properties. So below is the first 5 members of your alkane: methane, ethane, propane, butane, and pentane. All formulas will follow this CnH2n plus 2. Okay, what about the physical properties trend? When the size and mass of the molecules increases, a gradual change in the physical properties is observed. Boiling point will increase, density will increase, volatility will increase, flammability will decrease. So the first 3 parts we are really looking at: when size and mass increases, there is stronger intermolecular force of attraction between molecules. So more energy is needed to overcome the stronger IMFOA. So higher boiling point. Okay, this is the standard answer to write. If you're still not sure about this explanation, please look at the previous video. And then for flammability, right, percentage by mass of carbon increases. Count your percentage by mass of carbon in the compound, and then you will see that it increases, right? So you need more oxygen to convert the C to CO2. So it is less flammable. Okay, these properties will apply to all your organic compounds, not only alkanes. We will visit all these properties in the respective chapters. Okay, chemical reactions of alkanes. Alkanes are unreactive because they are saturated. You know, your carbon has already formed all the bonds it can possibly form. So it will undergo these type of reactions: combustion, substitution, and cracking. So combustion, when you see this word, you have to know it's burning. This reaction is highly exothermic. When you burn, example, methane, CH4 plus oxygen, right? It produces the flame. Energy is given out. This is the flame. Okay, it is exothermic. Okay, complete combustion, when there's enough oxygen, it will produce a blue flame without smoke. This one is like your Bunsen burner. When you open up your air hole fully, this allows all oxygen to rush in. The flame will be blue in color. Okay, complete combustion will always produce CO2, H2O as a product. Take as you know. Okay, so methane plus oxygen. Methane undergoes combustion. You have to know oxygen is your reagent. And you have to know the products formed are CO2 and H2O. Okay, in complete combustion, it will produce yellow smoky flame. If you close your Bunsen burner, the air hole, you close it halfway, less oxygen enters, you will see a luminous yellow flame. Okay, incomplete combustion will produce soot, carbon monoxide, and water. So soot is the burnt stuff that you see, right? When you go barbecue, the black stuff, that's your soot or carbon. It's carbon not burning completely. Carbon monoxide, one oxygen, CO. Instead of becoming CO2, it becomes CO, incomplete combustion. And water is your products. Okay, likewise, combustion reaction, this one will be applicable to all your homologous series, your alkane, alkene, alcohol, etc. Okay, the next reaction we are going to look at is substitution reaction. So substitution reaction takes place in the presence of light as the catalyst. Let's be accurate, like write UV here. Okay, presence of UV light. Okay, each hydrogen atom in the alkane is displaced one at a time. Let's not use the word displaced, let's say substituted, because this is a substitution reaction. Okay, so it's substituted one at a time by one halogen molecule. Okay, so your common halogens, the group 7, mostly the ones that have color, your chlorine, bromine. Okay, so for example, I have methane reacting with chlorine. So in this stage 1 reaction, it will break. Okay, your covalent bond will break in your chlorine, and then the CH, one of the CH bonds will break as well. Okay, so when it breaks, your chlorine gets substituted to the H substitute to the chlorine. So you will get a chloroalkane and HCl as your product. Okay, substitution reaction is important to know that this will take place one at a time. Okay, so the second part, you have another chlorine molecule, right? This is your substituted one already. Same thing, one of the covalent bonds will break, one of the covalent bonds will break, and then one of the chlorine comes over here, one of the H goes over there. So substitution, you get your dichloroalkane, one alkane got two chlorine, and your HCl. Okay, so your overall equation, you will get this. 2 HCl. CH3Cl in this case, CH3Cl plus Cl2, you get CH2Cl2 plus HCl. Okay, it is important to note that when you write your organic chem equations, right, you have to write the conditions on top. So you have to write UV light on top of your arrows.